Let's continue with this Lego activity. When you take all the possible samples with n equals 2, you should get 16 possible samples, as indicated by this table here. The possible combinations of first scores and second scores are here. And these are the corresponding sample means once calculated. I encourage you to check your own table for the correct sample means. After all that hard work, you're not done yet. Recall that we're talking about a distribution of sample means. A distribution is just a fancy word for what? A graph. So what happens when you graph all 16 sample means? Please pause the video and sketch a frequency histogram of the 16 sample means from the previous slide. All right. Does your graph look like this? Excellent. Then you have constructed a distribution of sample means. Get it? A graph of all the possible sample means from a population? Now, what shape does this graph look like? Does it look like a normal curve or a normal distribution? Yes, it does. A distribution of means will always form a normal distribution. Since the shape is a normal distribution, fortunately, we can still use the normal curve table from earlier in the textbook to find P or probability. In other words, we can use the normal curve table when conducting a hypothesis test with a sample. For this video, I've used the term distribution of means. Actually, there's several different terms that can be used. We can say distribution of means, or distribution of sample means, or a sampling distribution. Either way, it all has the same definition. A distribution of all the sample means of a given size n that can be taken from a population. Whew, that's a hefty definition. Let me explain this definition in reverse to help it make more sense. Remember that a population is the group we're interested in. But when a population is too large, we have to take a sample from a given size n. That n refers to whatever total number of people we want in the sample. Sample means is referring to calculating the mean for the sample. And then finally, distribution is a fancy word for graph. So we're just graphing all the combinations of sample means from a population. After first discovering the distribution of means, mathematicians tested it over and over and over again, and they did it with every possible sample size. And guess what? They found the same normal distribution shape. As such, mathematicians created a theory called the central limit theorem that explains the three basic rules of a distribution of means. This table summarizes the rules into notation, definition, and formula. Just as you've learned about mean, variance, and standard deviation of a regular sample, there's also a mean, variance, and standard deviation of a distribution of means. The subscript m refers to sample means. Each notation will have the subscript m to indicate that it is from a distribution of means. If you compare the computational formulas of variance and standard deviation to the ones from Chapter 2, you will see the same format here, just with the Greek letter sigma representing a population. The one significant modification is that standard deviation of a distribution of means is actually called standard error, as indicated by the star here. Please pause the video to take notes of the rules and formulas. Now that we've introduced the rules and formulas for a distribution of means, Are you ready to practice your new knowledge? I have one lecture example for you to review. A population of scores has a normal distribution with mu equals 200 and sigma equals 48. You select a random sample of n equals 64. What is the mean, variance, and standard error of the distribution of means? Please pause the video and complete these problems on your own. Resume the video when you're done to review your answers. So let's go over these answers. Question 1 asks, what is the mean of the distribution of means? Using the formula, mu m equals 200. Question 2 asks, what is the variance of the distribution of means? Using the formula, variance equals 36. For this formula, you're simply inserting the values of sigma and n into the formula. The most common mistake is that students forget to square sigma here. Question 3 asks, what is the standard error of the distribution of means? Recall that this is the technical term for standard deviation of a distribution of means. Using the formula, standard error equals 6. For this formula, you are simply inserting the value of variance here from the previous equation into the formula. The most common mistakes is that students see this square and think they have to square it, when all they really need to do is take this value here, put it into the formula, and square root it. In summary, a distribution of means is a graph of all the possible sample means from a population. This graph forms a normal distribution, which allows us to use the normal curve table when conducting a hypothesis test with a sample. A distribution of means is the first step in conducting research studies with samples and is an important Lego building block in understanding statistics.